Hello guys, welcome back. Myself Amit. So I am here with the continuation of influence line diagram concepts. So in this lecture series, I would like to take up some important charts and how to draw the influence line diagram for the particular section. Okay. First of all, some of the important charts that is to be remembered in this with respect to UDL. Okay. There is a UDL uniformly distributed load which is present. Okay. What is the placement of UDL upon the structure so that you are supposed to get the maximum shear force or maximum positive shear force or maximum negative shear force, absolute maximum shear force, absolute negative shear force, bending moment and all. So let me come to the first condition. See here, the shear force diagram will come like this. Okay, in this situation, the situation is given like this: maximum positive shear force at a point C. So let me take this point as A, B, and let me take this point as C. And how to draw the shear force I had already explained in the previous video. Now the placement of load upon the particular point is very important so that you are supposed to get the maximum positive shear force. In case of maximum positive shear force, see, this is the uniformly distributed load, and this point I'll call it as T because it is a tail end, and let me call this as H, which is called as head end. Okay, in this situation you are supposed to load the uniformly distributed load at a point C towards the tail end, and head should be here, so that with this pattern of loading you are supposed to get the maximum positive shear force at a point C. Next, maximum negative shear force means you need to put it like this, so that head is going to come at a point C and tail and in the inverse direction, in the other direction, which is a negative shear force. You need to apply the load towards the top. Here you are applying the load towards the bottom. Fine. Okay. Please remember this pattern. It is very much important while solving the MCQs. Or sometimes it may directly given in the MCQs also. Next, absolute maximum positive shear force. If you want to get the absolute maximum positive shear force, let me take this a point A, this point as C, and this point as B. You need to load in such a way that the tail end of the load has to be start from a point A and head end is going to end up here. Then in the same way, absolute maximum negative shear force, you need to load it like this from the point B. Okay, there is no matter of C here. This is the pattern of loading. Next, these two conditions are very much important. Please remember this. To get maximum bending moment in with respect to uniformly distributed load, you are supposed to load it like this. And we don't know this distance and this distance. The total distance here it is L. If you take this as a total distance, let me take this as A and this as B and this as X and this as L minus X. We are not supposed to load exactly at the center of the structure. How do you do the calculation? After taking this A divided by this X divided by B divided by L minus X. Please make a note of this thing. Next, for absolute maximum bending moment, don't get confused. It is just maximum bending moment. This is absolute maximum bending moment. It has to be loaded at the exact center of the point, but uniformly distributed load with some distance A and with some distance B. So A divided by L by 2 and B divided by L by 2, the L by 2 gets cancelled and it will be A is equal to B. Okay, please remember all these conditions. Okay, I will just explain you while solving the MCQs. I will come to this chart and I will tell you how the charts are to be used. Okay, next concept I am taking here is drawing influence line diagram, which is very important. Sometimes it will be directly asked in the MCQs. Drawing influence line diagram. First of all, I will take a structure. Okay, one overhanging structure like this with a roller support. Let me take this as a point A and this as a point B. Let this be 2 meters and let me take this as a point C, where here it is 2 meters, 4 meters and 2 meters. Okay, in the question they are asking us to find reaction at a point A, reaction at a point B, shear force at a point C and bending moment at a point C. These are the four things we need to For these four things we are supposed to draw the influence line diagram. Drawing influence line diagram is very much important here. Let me come to the first reaction at A. I am just drawing a line here. Okay, here I am going to find the reaction at A. I told you how will you find the reaction at A. Reaction at A, you need to find such a way that you are supposed to add 1 unit displacement, that is 1 unit displacement at a point A. Okay, this is how you are supposed to draw. After that, what happens? At a point B, it comes like this. Okay, up to here we have learnt in the previous video, but in this situation they have given the overhanging beam, so you need to extend it like this. It comes to be like this, and here it comes to be like this. This is reaction at A when there is a overhanging beam. Next, in the same way, if I wanted to draw reaction at B, I am just taking it as 1 unit at a point B. Is it fine? So then at a point A, it comes to be like this. This is the normal thing what we had already learned, but due to overhanging portion, it comes to be like this, and here it comes to be like this. So reaction at A is over, reaction at B is over. This is how influence line diagram will come for reaction at A, and this is reaction at B. Next, we need to calculate the value of shear force at C and bending moment at C. How will you draw the diagram shear force at C? See, I am just drawing it here. At a point C, it comes to be like this. Is it fine? So at a point A, and here this is at a point B. Point A, B, and this is point C. This is a usual thing we have already learnt in the previous lecture series. Since there is a presence of overhanging beam, it comes to be like this, and here this is a overhanging beam, it comes to be like this. This is the extra thing what we need to learn. And here, what is the value, what is the ordinate? This is what, this is what, this is A divided by L. What is the value of A is 2 meters, which is equal to 2 divided by 6, because the value of L is equal to 6. And here also B divided by L, the value of B is how much? B is 4 divided by 6, which comes to be 0.66 something. Okay, this is how you need to remember. Then the remaining is bending moment at C. How will you draw that bending moment at C is very important. See, I'm just taking bending moment at C, so that the ordinate will come here. At a point A, it comes to be like this. A, B, this is what we have already studied in the previous things. But extra thing is, due to overhanging portion, it has to be continued like this. It has to be continued like this. And this ordinate will be what? AB divided by L. What is A? A is 2 and B is 4 divided by L is 6. 2 4s are 8 by 6 will be your ordinate, which comes to be 1.33 meters will be your ordinate. Let me take this as theta 1, this as theta 2, and if you take the opposite angles theta 1, and this will be theta 2. This is influence line ILD for reaction at A, ILD for reaction at B, influence line diagram for shear force, influence line diagram for bending moment. Okay, drawing influence line diagram is very important, because in the numerical problems what they will do with respect to this, they will give you the structure like this, and they will give you the train of the point load. For that, initially if they are asking you to find the bending moment, then you need to know how to draw the influence line diagram with respect to bending moment. After that, you need to place this train of point load upon this point. So I am taking many examples how to draw the influence line diagram for different kinds of structures. Okay, this is first one. Let me come to the second one. Yes, let me come to the second one. I am taking one more example in which let the structure be like this. This is a roller support, and here it is roller support. Point A, point B, point C, and there is a internal hinge is present here. Okay, this is nothing but internal hinge. Internal hinge is nothing but a scissor. It acts as a scissor. That means if there is an internal hinge present here, the bending will take place either like this or either like this. Please remember this point. Okay, I'm sorry. If there is an internal hinge which is present, if it is present on the structure, either the structure may bend like this, or structure may bend like this. It acts as a scissor. That is the thing which you need to remember. Okay, internal hinge concept is very much important. Fine. Yeah, in this question they are asking to find the reaction at a point A, reaction at a point B, one more reaction at a point C, then bending moment at a point B. First let me find the reaction at a point A. Reaction at a point A can be written 1 unit at a point A. Is it fine? So after that what happens? The reactions comes to be like this, B. Okay. In case if the internal hinge, if it is not present at this position, then we would have end here itself. But since there is a presence of internal hinge, now the structure is going to, the moment is acting like this, so the structure is going to bend like this. Okay, this is the reaction at a point A. So if this is 1 unit, what is the ordinate? Ordinate can be found by making use of similar triangle concept. Okay, next, reaction at a point B. How will you find the reaction at a point B? Very simple. Same thing. And at a point B, I am going to apply 1 unit load. And it comes to be like this. This is the thing what you already know. But I'll just rub it off. Yes. Okay. But since there is a presence of internal hinge at this position, it comes to be so this will be 1 unit, and this ordinate can be found by making use of similar triangle concept. This is reaction at point B. Then reaction at a point C. How will you write the reaction at a point C? C. Very simple. At a point C, I am going to apply 1 unit load. Okay, 1 unit load at a point, but it ends at this position. That is at a point D. At the point D, it is going to end. That is the reaction at C. Please remember. And this comes by practice. Okay, if you do many by taking many types of structure, go draw the influence line diagram. By practice, it will be much more clearer to you. Next, they are asking us to find the ILD for bending moment at a point B. Moment at B is very simple. It is a point B. This is point C. Since internal hinge is present here, it comes to be like this. This is influence line diagram for moment at a point B. Okay. Fine. Let me take some more examples so that it will be much more clearer to you. Fine. Next question. Next question is like this. There is a structure like this. This is a point A, and there is one internal hinge is present here. Okay. Now, influence line diagram for bending moment at a point A. Let me take this point as A. Okay. This distance is A, this distance is B, this distance is C, and this distance is D. This is the point A. We need to draw the bending moment at a point A. At a point A, the bending moment will come like this. In case if there is no internal hinge is present here, then only it would have been end here, but since internal hinge is present here, the moment is taking place in this direction, it comes to be like this. Okay, so what is this ordinate? A into B divided by A plus B. This ordinate can be found by making use of similar triangle concept which I had explained earlier. Let me come to the next question. Some of the simple questions. Let me take one cantilever beam like this. Let me take this as a point A, and this is L and this is A. Then they are asking us to find bending moment at point A. Will you draw the influence line diagram? Influence line diagram, you are supposed to draw it like this. It comes to be like this. Okay, if this is A and this ordinate will become A, this is special condition, please remember. Fine, let me come to next question. Yes, let me take one structure here. This is one internal hinge is present here. Fine, and this is a point A. They are asking us to find the bending moment at a point A. Draw the influence line diagram for bending moment at a point A. For this, what I am going to do, the bending moment will come in such a way that if this is the point, and in the question they have given one more internal hinge here, it comes to be like this. Okay, since internal hinge is present here, it comes to be like this. It comes to be like this. Is it fine? So in the previous problem we have studied one thing. See, there is no internal hinge, so it comes to be like this. Please make a comparative study of all the things. Okay, this is one more example. Now I will take one big numerical so that it will be okay. Please listen it carefully. One structure is coming like this. Let me take this as a point A, this as a point B. Here presence of roller which is mentioned as a point C, D, point E, point F, and roller which is point G. Fine, C. Let me take this as D, E, F. Okay. For this structure, for every concept I am going to explain here. See, initially what I am going to do, reaction at a point G. This is reaction at a point G, so that I am going to apply 1 unit load here and it is going to end here. So this is the influence line diagram for reaction at G. This is point F. Okay, ILD for reaction at G. Now I am finding fine reaction at a point E. ILD for reaction at a point E. I'm just taking it like this. E, here it is 1 unit. Is it fine? So here it is D. It is going to end here. But here the structure is like this. The moment is applying in this direction. So it comes to be like this. This is a point F and this is thing. Since this is 1 unit, this ordinate can be found by making use of similar triangle concept. This is influence line diagram for reaction at a point E. Next, I am taking the reaction at a point C. For C, I am giving 1 unit load. Then what happens? If it is 1 unit load, it ends in the left hand, it ends at a point A, and this is at a point B, and this is point C. But in the right side there is a internal hinge which is present here, so the moment is acting in the upward direction. Okay, I'm just rubbing it this. Moment is acting in the upward direction, so it comes to be like this at the point D. Okay, then at a point E it is getting hinge. Since there is an internal hinge present here, the moment is acting upon this direction, it comes to be like this. So this is the ordinate. Since we know the value of the ordinate, since it is 1 unit, the remaining ordinates can be found by making use of similar triangle concept. Next, moment at a B, bending moment at a point B. See, this is the point B where I need to find the bending moment at a point B. Okay, this is point A, this is point C, this is point B. Ordinate can be found by AB divided by L. If I take this as A, this as B, AB divided by L. Then the remaining thing. Now the moment at a point D with respect for bending moment, it will act in the downward direction. Like this, it will be acting in the downward direction. So it will come down. Means it will come down. Then it ends at point E. Here it will act in the upward direction. So it comes up and it ends here. So this is the bending moment at a point C. Influence line diagram of a bending moment at a point B. Then influence line diagram for a bending moment at a point C. How will you write? Yeah. At a point C. See, this is the point C. It comes like this. Then at a point E, it ends here. Then this is the point F and point G. Okay, take many numerical problem with respect to different types of structure and try to draw the influence line diagram. It will be good practice. If you do by practice, it will come how to draw the influence line diagram for different things. See, in some, when there is a presence of internal hinge, when there is a presence of some of the supports and all, it will be little confusion. The confusion can be cleared by solving many MCQs. That's all. Remaining things we'll study in the next session. Thank you and all.